So let's go ahead and use the intermediate value theorem to help us perhaps apply it to some of these examples. Now, in order to use the intermediate value theorem, we have to first check two conditions. So if these two things are true, then we can go ahead and try to figure out where is that special spot in the interval that would have a specific y value. So we have to check these two conditions. The first one was that f of x, okay, your function, is continuous on the interval. So they're always going to give you an interval. We just got to check to make sure there's no hole, no jump, no asymptote in between those values. So it has to be continuous. The second thing is we have to make sure the y value that we have available to us is between the outputs from that interval. So we got to make sure the y value, I'm going to use f of c as the notation for that. So the y value must be between, if I say the outputs from the interval, I mean f of a and f of b. Okay, the y values from a and from b. So we got to check those two things first. So if we take a look at number one, take a look at the function, and we got to ask ourselves, is it continuous on the interval from -1 to 3? So if you take a look at it, since it's a fraction, we definitely have to be careful about the denominator, and the x value of -2 would cause this fraction to be undefined. Specifically, we would have an asymptote at that location. So the x value of -2 is important for us to be aware of, but notice how the x value of -2 is not specifically in the interval that we are focusing on. So even though the function is discontinuous, it is not discontinuous on the interval. Therefore, if it's not discontinuous, double negative changes that to the result that it is continuous. So let's go ahead and try to summarize that. So f of x is discontinuous at x equals -2. Okay, that results in a vertical asymptote, but this is not in the interval, so f of x is continuous on the interval. Okay, a lot of thinking just happened there. So we analyzed where it was discontinuous, but notice how it's not an issue because it's not in the interval that we want. So the first criteria checks out. We are continuous in the specific region of the graph that we are focusing on. The second thing is we got to make sure the y value that we have is between the y values from the interval. So notice how the y value we have, f of c, is 2/3. So we got to check to make sure that 2/3 is between the outputs from -1 and -3. So let's check out the output from -1. If we were to plug in -1, we would get -4 over 1, so that's -4. And if we were to check 3, we would have 0 over 5, which is 0. So if we take a look at these outputs and relate it to the y value we know, clearly 2/3 is not between our outputs, so that means our second condition is failing. Okay, it's not between the outputs from the interval. So we'll say 2/3 is not between -4 and 0, so the intermediate value theorem, or IVT for short, does not apply. Okay, we are not guaranteed to have an x value between -1 and 3 that would have a y value of 2/3. Now, since we are not guaranteed that, that doesn't mean that there is not a point that satisfies that information. Like the previous page said, we're just checking to see if it's guaranteed. There may be one, there might not be one, but we are just not guaranteed that there absolutely is one. Let's go ahead and check out number 2. So it's actually the same equation, and they changed the interval on us. So previously we said that f of x is discontinuous at -2, but notice how -2 is now within the interval. So this time the intermediate value theorem fails because we do not satisfy that first condition of continuity. So we'll say f of x is discontinuous at x equals -2 because of that vertical asymptote, and this is in the interval, so the intermediate value theorem does not apply. Okay, notice how it's the same equation, but the intermediate value the intermediate value theorem fails for a different reason. The first one was because the output of 2/3 was not between the outputs for the interval, but the second one was because it failed due to being discontinuous. So we have to check both criteria. It has to be continuous and the y value is between the outputs from the interval. Let's go ahead and check out 3 at the bottom. So we have our function, we have an interval, and it looks like our output is 5. So we first have to check continuity. Now, if you think about the way the equation is written, notice how we have an exponential function times a trig function. So exponential function looks like this because we have that base bigger than 1, and cosine is our wave. Notice how both of those graphs are continuous, no holes, no jumps, no asymptotes. So if we were to multiply the graphs together, a continuous graph times another continuous graph would result in a continuous graph. So p of x is continuous on the interval. If you wanted to graph it on your calculator just to confirm, you would get the same result, but we can think about the individual graphs in that manner. Let's go ahead and check out the second criteria. So we got to make sure that this output of 5 is between the outputs from the interval. So if we were to go ahead and plug in -2, you can go ahead and use your calculator for this. Go ahead and plug in -2 for the x's. We should get -0.416. And if you were to plug in 1 in for all those x's, we should get 10.852. Again, since we're dealing with trig, make sure you're in radian mode. So notice how 5 is between the outputs from the interval. 5 is between -0.416 and 10.852. So the intermediate value theorem does apply. So that means there should be some x value between -2 and 1 that would have an output of 5. And we're actually going to go ahead and try to figure that out. So we're going to go ahead and use this equation to help us with that. We specifically want an output of 5. So we can set this equation equal to 5. And we're going to go ahead and try to figure out that special x location. And according to the IVT, it should be between -2 and 1. Now, this is definitely tricky, probably not going to be able to do this by hand, so we'll go ahead and use our calculator to help us find this x solution. Now, to use your calculator, we'll go ahead and graph. So we'll type in e to the x plus 2 power times cosine, and then in y2, we'll go ahead and graph 5. I just have a standard window of -10 to +10, and we may have to change that, but we'll go ahead and see kind of what happens. So we do have that crazy graph. It might be useful, notice how we do have quite a few locations where the function equals 5, but we're really only interested in the interval from -2 to 1. So on our window, maybe we'll just change the x values from -2 to 1, because that's all we're really concerned about. So there's our function, there's the value of 5, and we are interested in that intersection point to figure out the x location. So to find the intersection, we'll hit second and then trace. Option number 5. We're going to move the little cursor to where we think the intersection is and hit enter 3 times. It looks like our x location is -0.3338, and notice how that x location is between -2 and 1 like the IVT said it should be.